How to build and deploy a Solana smart contract. If you want to learn how to develop Solana smart contracts and programs, then you've come to the right place. Solana is an emerging high-performance, permissionless blockchain that offers fast, cheap, and scalable transactions and supports smart contracts being built with the Rust, C++, and C programming languages. In this technical article, we will go through examples of writing, deploying, and interacting with smart contracts on the Solana DevNet cluster, as well as how to use Chainlink price feeds in your Solana smart contracts. Solana's architecture and programming model. Solana is a high-performance blockchain capable of thousands of transactions per second and sub-second block times. It achieves this via a Byzantine fault-tolerant (BFT) consensus mechanism that makes use of new innovative cryptographic function called proof of history. Proof of history. Proof of history (POH) establishes a cryptographically verifiable order of events, in this case transactions, over time via the use of high-frequency verifiable delay function or VDF. Essentially, this means POH is like a cryptographic clock that helps a network agree on time and ordering of events without having to wait to hear from the other nodes. Much like how an ancient water clock can record the passage of time by observing rising water levels, proof of history's sequential outputs of constant, hashed blockchain state give a verifiable order of events over time. This helps the performance of the network by allowing the ordered events to then be processed in parallel, as opposed to a traditional blockchain scenario where a single process verifies and bundles up all the transactions to be included to the next block. A simple analogy would be to imagine a large 100-piece puzzle. In a normal scenario, it would take one or more people a certain amount of time to complete this puzzle. But imagine if beforehand the puzzle pieces were all stamped with a number corresponding to their position, from top left to bottom right of the puzzle, and laid out in a line in sequential order. Because the exact order of puzzle pieces and their position in the puzzle is known beforehand, the puzzle can be solved quicker by having multiple people focus on a section each. This is the effect that having a verifiable sequence of events over time has on the consensus mechanism. It allows the processing to be broken up into multiple parallel processes. Smart contract architecture. Solana offers a different smart contract model to traditional EVM-based blockchains. In traditional EVM-based chains, contract code, logic, and state are combined into a single contract deployed on-chain. With Solana, a smart contract, or program, is read-only or stateless and contains just program logic. Once deployed, smart contracts can be interacted with by external accounts. The accounts that interact with the programs store data related to program interaction. This creates a logical separation of state accounts and contract logic programs. This is the crucial difference between Solana and EVM-based smart contracts. Accounts of Ethereum are not the same as accounts on Solana. Solana accounts can store data, including wallet information, as opposed to Ethereum accounts, which are references to people's wallets. In addition to this, Solana offers a CLI and JSON RPC API that can be used by decentralized applications to interact with the Solana blockchain. They can also use one of the existing CDKs, which allows clients to talk to the blockchain and Solana programs. Deploying your first Solana smart contract. In this section, you'll create and deploy your first HelloWorld Solana program, written in Rust. Requirements. The following should be installed before proceeding: Node.js v14 or greater and npm. The latest state Rust build, Solana CLI 8 version 1.7.11 or later. Git. The HelloWorld Program. The HelloWorld Program is a smart contract that prints output to the console and counts the number of times the program has been called for a given account, storing the number on-chain. Let's break down the code into separate sections. The first section defines some standard Solana program parameters and defines an entry point to the program, the process, instruction, function. In addition to this, it uses BOSH for serializing and deserializing parameters being passed to and from the deployed program. The process, instruction, function accepts the program ID, which is the public key where the program is deployed to, and account info, which is account to say hello to. The program results is where the main logic of the program resides. In this case, it simply prints a message, then selects the accounts by looping through accounts. However, in our example, where will only be one account. Next, the program checks to see if the account has permission to modify the data for the specified account. Finally, the function takes the existing account's stored number, increases the value by 1, writes the result back, and displays a message. Deploying the program. The first step is to clone the repository. Once this is done, you can then set your current environment to DevNet. This is the test network for Solana developers writing and testing smart contracts. Next, you need to create a new key pair for your account. This is required to interact with deployed programs, smart contracts, on Solana DevNet. Take note, this is an insecure method for storing keys and should only be used for demo purposes. You will be prompted to enter in a passphrase for security reasons. Now that you have created an account, you can use the airdrop program to obtain some SOL tokens. You will need some lamports, fraction of SOL tokens, to deploy your smart contract. This command requests SOL tokens into your newly generated account. You are now ready to build the HelloWorld program. You can build it by running the following command. Once the program has been built, you can then deploy it to DevNet. The previous command's output will give you the command that you need to run, but it should look something similar to the following. The end result is that you have successfully deployed the HelloWorld program to DevNet with an assigned program ID. This can be checked on the Solana DevNet Explorer. Interacting with the deployed program. To interact with the deployed program, the HelloWorld repository contains a simple client. This client is written in TypeScript using the Solana Web3.js SDK and the Solana Web3 API. The client. The client entry point is the main.ts file, which performs a number of tasks in a specific order, most of which are contained within the helloworld.ts file. First, the client establishes a connection with the cluster by calling the establishConnection function. It then calls the establishPlayer function to ensure there is an account available to pay for transactions and creates one if required. The client then calls the check program function, which loads the key pair of the deployed program from .dist program HelloWorld key pair.json and uses the public key for the key pair to fetch the program account. If the program doesn't exist, the client stops with an error. If the program does exist, it will create a new account with the program assigned as its owner to store the program state, which in this case is the number of times the program has been executed. The client then builds up and sends a hello transaction to the program by calling the sayHello function. The transaction contains an instruction that holds the public key of the HelloWorld Program account to call and the account to which the client wishes to say hello to. Each time the client performs this transaction to an account, the program increments a count of the destination account's data storage. Finally, the client requires the account's data to retrieve the current number of times the account has had the sayHello transaction called by calling report greetings. Running the client. Before you can run the client to read data from your deployed program, you need to install the client dependencies. Once this is done, you can start the client. You should see output showing your program successfully being executed, and it should display the number of times the account has been greeted. Subsequent runs should increase this number. Congratulations, you've deployed and interacted with a Solana smart contract on the DevNet network. Now we will dive into another example Solana program and client, except this time we'll make use of Chainlink price feeds. Chainlink price feeds on Solana. The ecosystem of DeFi apps on Solana is growing at an accelerating rate. In order to power basic DeFi mechanisms and execute key on-chain functions, such as issuing loans at fair market prices or liquidating under-collateralized positions, the apps need access to highly reliable and high-quality market data. Solana recently integrated Chainlink price feeds on their DevNet network, offering developers highly decentralized, high-quality, high-speed price reference data for building hybrid smart contracts. When combined with Solana's ability to support up to 65,000 transactions per second and its extremely low transaction fees, Chainlink price feeds have the potential to empower DeFi protocol infrastructure that can compete with traditional financial systems in terms of trade execution and risk management quality. In this next code example, we'll deploy and interact with a Solana program that makes use of Chainlink price feeds on the Solana DevNet. Requirements: Node.js version 14 or greater and NPM, the latest stable Rust build, Solana CLI version 1.7.11 or later, GIT. The Chainlink Solana Demo Program. The Chainlink Solana Demo Program is a smart contract that simply connects to a Chainlink price feeds account on DevNet and retrieves and stores the latest price of the specified price pair. Chainlink price feeds on Solana all utilize a single program. With each individual price, feed a separate account that submits price updates using the program. The first section consists of normal includes and declaring using Borscht for serializing and deserializing parameters, being passed to and from the deployed program. In addition to this, some structs are set up for storing price feed, answers, and decimal data. Next, the program declares the entry point for the program to be the process instructions function. Finally, the process instruction function is the part of the program that contains the main logic for the smart contract. It receives the transaction with the specified feed address and handles the steps to retrieve and store the price data on-chain. The function also calls getPrice from the Chainlink Solana package, which gets imported from GitHub via the cargo.toml file. The function finishes by storing the price against the specified account. Deploying the program. The first step is to clone the repository. Once this is done, you can then set your current environment to DevNet. This is the test network for Solana developers writing and testing smart contracts. Next, you need to create a new KPI for your account. This is required to interact with deployed programs, smart contracts, on the Solana DevNet. Again, this is an insecure method for storing keys and should only be used for demo purposes. You will be prompted to enter a passphrase for security reasons. Now that you have created an account, you can use the airdrop program to obtain some SOL tokens. You will need some lamports, fractions of SOL tokens, to deploy your program. This command requests SOL tokens for your newly generated account. If this doesn't work, you can see your public key with the following command, and then use it to request SOL tokens from the SOL faucet. You're now ready to build the Chainlink Solana demo program using Solana BPF. Once the program has been built, you can then deploy it to DevNet. The previous command's output will give you the command that you need to run, but it should look something similar to the following. Take note of the KPI flag appended at the end. The end result is that you have successfully deployed the HelloWorld program to DevNet with an assigned program ID. This can be checked on the Solana DevNet Explorer. Interacting with the deployed program. To interact with the deployed program, the Chainlink Solana demo repository contains a client written in TypeScript using the Solana Web3.js SDK and the Solana Web3 API. The client. The client entry point is the main.ts file, which performs a number of tasks in a specific order, most of which are contained within the HelloWorld.ts file. First, the client establishes a connection with the cluster by calling the establishConnection function. It then calls the establishPair function to ensure there is an account available to pay for transactions, and creates one if required. The client then calls the checkProgram function, which loads the KPI of the deployed program from deploy Chainlink Solana demo KPI.json and uses the public key for the KPI to fetch the program account. If the program doesn't exist, the client stops with an error. If the program does exist, it will create a new account with the program assigned to its owner to store the program state. The client then builds up and sends a transaction to the program by calling the getPrice function. The transaction contains a price feed account as a parameter. In this case, you are sending the SolUSD feed account listed in the Chainlink Solana DevNet feeds page. Once it sends the instruction, it waits for the transaction to confirm. Finally, the client requires the account's data to retrieve the stored price obtained from the SolUSD price feed. Running the client. Before you can run the client to read data from your deployed program, you need to install the client dependencies. Once this is done, you can start the client. You should see output showing your program successfully being executed, and it should display the stored current SolUSD price. Summary. Solana offers a high-speed, low-cost, scalable blockchain for building smart contracts and decentralized applications. By leveraging Solana smart contracts and Chainlink price feeds, developers can create fast, scalable DeFi applications. Taking advantage of the high-quality data offered by Chainlink price feeds and the high-speed updates available on the Solana blockchain. To explore more Chainlink technical tutorials, check out the engineering video tutorials playlist on the official Chainlink YouTube, and visit the Chainlink documentation at docs.chain.link. To discuss an integration, reach out to an expert. The Chainlink Fall 2021 Hackathon kicks off October 22, 2021 when you're a developer, creator, artist, blockchain expert, or completely new to the space. This hackathon is the perfect place to kickstart your smart contract development journey and learn from the industry-leading mentors. Secure your spot today to compete for over 300,000 in prizes.